Hello. Today we're going to talk about one of my favorite subjects in the world, artificial intelligence, and one of my favorite companies, Micron Technologies. Micron Technologies is no longer a commodity supplier. I think they're supplying a very special product that is incredibly necessary for machine learning and for artificial intelligence. But to start this conversation, let's talk about artificial intelligence. What kind of types of artificial intelligences are there? Artificial intelligence is generally divided into strong AI and weak AI. Strong AI is stuff like, for instance, Commander Data on Star Trek or Wall-E from the movie Wall-E. It's a general purpose AI that can learn new things, can act more or less like a human, and can have all kinds of human-like characteristics. By contrast, weak AI is a specific purpose AI. Now, weak AI is a bit of a misnomer because it could be actually incredibly powerful, as we're about to see in a few seconds. But weak AI is things like, for instance, categorizing pictures of cats or identifying cancer on radiology scans. It could be very, very powerful, but it's not general purpose. It's specific to a very narrow application. So let's look at some AI that exists today in today's day and age. This, for instance, is a video from Boston Dynamics of their robots walking around. The Boston Dynamics is a robotics company that works with the Department of Defense and with DARPA to develop robots to go where humans are not able to go. I really like this part of the video where you could see this dog-like robot opening the door, and pay attention to its feet, how it braces itself as it's sliding forward. It's very animalistic, it's very self-aware, one might say. But it is just artificial intelligence. Here's another one. Here's an example of AI doing something one might call creative. Here's another example. This is a photograph of my wife Yuki and a photo of some street art or some graffiti that was taken, and the computer, the artificial intelligence program, took those two photos and combined them into something new, something creative. And I think it's quite spectacular. And here's a final example that we're going to take a look at today. This is Cruise Automotive, which is a company that was purchased by General Motors just recently. And their self-driving car driving completely autonomously through downtown San Francisco during rush hour traffic. I think that's quite impressive. So what's behind this explosion in artificial intelligence in the recent decade or so? For the most part, it's actually a change in approach. For a long, long time, we followed the rule-based approach. And the rule-based approach is nice because it doesn't require that many resources. It requires some very clever coding and creating very clever decision trees for the artificial intelligence to follow. But the problem, of course, there is that it requires very clever coding. It requires a lot of thinking. And it also requires you to really understand the subject matter that you're trying to teach the computer, which is sometimes difficult to do. Like, for instance, how would you come up with rules to identify if a picture contains a cat or not? Some cats are furry, some cats are kind of, there's even those cats that have no fur, for instance. So it's very difficult to create rule-based approaches to artificial intelligence. By contrast, machine learning is a process of showing your computer a problem, having the computer guess what the answer should be, and then telling the computer what the right answer should be, and allowing the computer to take that information, to take the error, to calculate the error that it has, caused by guessing incorrectly, and then propagate that error back through its model to adjust the weights inside the model. And that teaches the computer on how to get the answer correct the next time around, or how to get it closer and closer to the correct answer. And this kind of approach isn't necessarily new. In terms of academia, this approach has been discussed since the 1970s and in the 1980s and the 90s during what people commonly refer to as the AI winter. This approach has not been lost. But until recently, the calculational power to actually take advantage of this approach hasn't really been available. This approach requires a lot of linear mathematics, which is basically taking huge data sets of numbers and multiplying them or dividing them, etc., by other large data sets of numbers, which is linear mathematics. And until recently, we didn't have the hardware to really do that in any efficient way. But now we do, thanks to things like Moore's law, for instance. As many of you might know, Moore's law is a suggestion that the number of transistors on a processor will double every 18 months. And we have been holding very steadily true to that idea. And this is Moore's law shown on a logarithmic scale. And this is Moore's law shown on a linear scale. And as you can see, the power of the processors, when we can see it on a linear scale, has literally exploded since 2010. And it's only continuing to explode further, right? Following the Moore's law. And likewise, the resources that have been dedicated to machine learning have also exploded. This graph, for instance, shows the resources dedicated to machine learning from 2012 to present day on a logarithmic scale as well. And here's the same graph on a linear scale. And as you can see, from 2016, we just have this explosion in terms of resources dedicated to machine learning. And I think this is what's behind the machine learning and AI renaissance that we're experiencing right now. For machine learning, or for any compute task in general, you need something that I commonly refer to as the compute triangle. And the compute triangle has the CPU on top and the GPU and the memory on the bottom. And for machine learning, you need the CPU to run the actual program. You need the GPU because that's what does all the heavy lifting for doing all those linear math calculations that I was talking about. Because the GPU is basically like a 4-function calculator on steroids. It can divide multiplied numbers dramatically fast because it has all these parallel compute cores. And of course, you need memory because memory is behind everything. Memory is what stores the model. For this reason, I like to see this compute triangle with memory on top for 2 reasons. First, I think memory is what feeds both the GPU and the CPU. It's what contains the actual code, the part that does something useful. And also, it is the current bottleneck. Computers spend a lot of their time simply waiting for data to arrive so they can start computing, so the processor can start processing it. And the more memory you have, the more you can load your GPU and your CPU with information. Just to also further illustrate how important memory is, here's a snapshot, for instance, of I think it's an i7 processor under a scanning microscope. And if you look at the very middle of it, the square in the very center of that processor is memory. So about 50% of the surface area of the actual die of the CPU is dedicated to simply memory, in this case, SRAM. And here's a graph of all the memory that is currently available for different types of, inside a computer, different types of memories inside a computer. And it's organized from the fastest memory down to the slowest memory that we have. So we start with that SRAM that I just talked a few seconds ago about, which is static random access memory. That is used primarily inside the CPUs themselves. It's very, very fast. It has incredibly low latency. Latency is a measure of how fast something reacts. So when a CPU asks for some information, this type of memory can just instantly feed it back to the CPU, right? So it has very low latency. It's very fast. But it has very low density as well. It requires quite a bit of space on the CPU to put a few megabytes of that memory in there. By contrast, DRAM, which is what we usually use as operating memory inside a computer, has much higher density. It's 100x density, so it's you can store a lot more stuff in a square millimeter of the die, for instance, right? But it has also higher latency. It has about 10x latency, which is still pretty good, but obviously worse than the SRAM. And then we'll skip over 3D XPoint and let's look at NAND memory, which is primarily used in hard drives and SSD drives. That one has 1000x density, so it's even more dense than DRAM, far more dense than DRAM, about 10 times, which means you can store a lot more stuff on an SSD drive than you can, for instance, in DRAM. But at the same time, it has 100,000x latency, which means it has pretty high latency, and it's inefficient for purposes of, for instance, direct CPU access, where the CPU can directly pull some chunks of memory and work on them. Because it has such a high latency, the CPU would simply spend most of its time just waiting for this type of memory to respond. And of course, in this chart, we also have spinning disk drives, which are very, very dense, but incredibly high in latency. So those are not worth talking about at the moment. But let's look at 3D XPoint. 3D XPoint kind of combines the benefits of NAND memory because it has very high density, 1000x. It has persistency, which means it doesn't get erased if the computer shuts down or something like that, or there's a kernel panic or the software crashes. But at the same time, it has rather low latency. Now, it's a little higher than DRAM at about 100x, but it's still fast enough latency where you can fully load up that CPU and make it work at its full capacity. It doesn't have to wait around for memory. And as a result, 3D XPoint is kind of like this middle ground. It has both low latency and high density, and is also persistent, by contrast to DRAM and NAND, DRAM being both low latency and low density, and SDRAM having high density but also high latency. And here's another graph that kind of illustrates this point further. This is a graph from SSD Review's website, where they show their tests for different types of SSDs, a bunch of different SSDs. And one of these SSDs is a little easy to miss because it's all the way on the bottom. And it's the Intel 900P, which is a 3D XPoint based SSD. And in this particular graph, it's better to be at the bottom. The lower, lower your latency is, the better. And as you can see, the Intel 900P is right there at the base, right there at the bottom. And that's even communicating over a connection that's not really designed for memory. So I think 3D XPoint is basically going to be a new memory paradigm. I like to kind of think about it in human terms. As humans, we have short-term memory and we have long-term memory. Short-term memory is something you would associate with, for instance, you listening to this presentation and you kind of taking things in, but they're going into your short-term memory because you haven't gotten a chance to think about them yet and kind of memorize them in case you wanted to do that. Long-term memory is things like your phone number, your name, the name of your kids, your social security numbers, things like that. Things that you remember pretty well for a really long time, right? But if you think about it, there is also something that's called medium-term memory. There's a concept that actually fits there in the middle. And that's something that you use when you, for instance, studying for a test and memorizing a bunch of facts, memorizing a bunch of data, kind of learning a new task. And then maybe you'll take a test on that task. Maybe you'll take a test on that particular class. And then you just kind of forget. It floats out of your memory. Or maybe you're paying attention to this presentation. You're going to do some more research. And that's going to go into your medium-term memory. But eventually, if you're not really interested in the subject, for instance, it'll just float out of your head. And similarly, in computers, right now, we only have those two paradigms. The short-term memory paradigm, which is RAM. It's expensive, it's slow, it's rather fast, but it's not persistent. And then you have SSD, which is slower, but persistent. And it's meant to store things for like long-term storage, essentially. But with 3D XPoint, we can get that third paradigm. We can have memory that is both persistent and fast. And it would be used for things like storing the model, for instance, for machine learning, or storing applications and files for the operating system that you access all the time, right? And with software support, with operating system support, this will be an exponential increase in how fast and how snappy computers can operate, because the CPU can directly reach into 3D XPoint and grab a piece of data and just start working with it. It doesn't have to wait for it to be loaded into RAM before it can start working on it. So for that reason alone, I think 3D XPoint is going to revolutionize computers. And this is not just something in the future. This is actually available today. It's not available to for people to buy yet necessarily, but Intel is already shipping engineering samples of 512 gigabyte DIMMs of this type of memory to their partners. So, and 512 gigabyte DIMM, that's the type of stick that you insert for operating memory inside a computer. That's pretty impressive. And it's available today, and it's going to be widely available in the first half of 2019. And that brings us back to Micron. Now, I started this presentation by making an argument that Micron is no longer a commodity company. And people say that Micron is a commodity company because they're one of 4 companies that can make, for instance, DRAM. And they're one of 1, 2, 3, 4, 5, or 6 companies that can make NAND. So yeah, I mean, it's logical to make an argument that they may be a commodity company when it comes to those 2 types of memories. But when it comes to 3D XPoint, this is their brainchild. Micron and Intel developed this together, and they have contractual obligations to each other, and they have patents on this technology. So for the foreseeable future, 3D XPoint is going to be made by only one of 2 companies, Intel or Micron. And I believe that Micron is going to do quite well. I think Intel is going to do quite well with 3D XPoint. But I think for Micron, it can really move the needle on their stock price. And I think it could really move the needle on their earnings and on the profitability of the company itself. And in that particular case, they're not a commodity supplier, because they're one of 2 companies, they're in a duopoly, who can make that memory. Now, it is true that Intel and Micron have kind of broke up recently, and they went their separate ways in terms of developing the next iteration of 3D XPoint, but still, they're one of 2 companies who have this technology and will have this technology for the foreseeable future. And 3D XPoint, I think, is going to be huge for all kinds of applications, from self-driving cars, to robotics, to automation for production automation, to artificial intelligence online and offline, trying to streamline a lot of processes, to even things like virtual reality. And I think automation in general right now is kind of at a little bit of a pause, because the economy is pretty good, the companies that make money. But I think automation is going to hit a new stride when, unfortunately, we do have another recession. Companies generally invest in automation dramatically right after a recession or during a recession. For instance, in 2008, a lot of companies invested in automation. I just heard that McDonald's, for instance, is going to put more and more iPads to do ordering in their companies in the foreseeable future. So as a result, I think memory is going to become a much more important commodity. And from that commodity, the 3D XPoint is going to be a very, very unique offering that is going to be offered by 2 companies and is going to be in huge demand. Because as a society, we are creating more data at a higher rate than ever before. Millions of hours of video get uploaded to YouTube. Billions of pictures get uploaded to Facebook every day. And that's not going to go away anytime soon. So as a result, I think Micron still has a lot of room to grow. We've been investing in Micron since 2016 or so on the premises of this 3D XPoint, primarily because of that. Now, Micron has done very well due to the increase in price of DRAM and NAND that has made them grow quite a bit in the last couple of months or a year or so. But I think they have another growth spurt in their future due to 3D XPoint. I hope this presentation has been interesting to you. If you have any questions, please leave them in the comments down below the video. And I hope you learned something today.